So, as mentioned in the email this video is attached to, two carpenters are carrying a uniform 6x6 beam. The beam is 8 feet or 2.44 meters long and weighs 425 newtons. One of the carpenters, being a bit stronger than the other, agrees to carry the beam 1 meter in from the end. The other carries the beam at its opposite end. What is the upward force exerted on the beam by each carpenter? Well, the first thing I did here is write down what I know, and that is that the sum of the forces is equal to 0 and the sum of the torque is also equal to 0. But with this problem, I found that it was easiest to go ahead and start with the torques. So what I did was choose the axis of rotation where one of the unknown forces acts, and then that force has a lever arm of 0, and that means that it has a torque of 0. So the torque equation was I used to solve for the unknown force, and then with the only one force still unknown, I set the sum of the y components of the force is equal to 0. And then one of the other first things I did was draw a force body diagram, and for each force I drew at the point where it acts and labeled the known distances. So again, I chose a rotation axis that was perpendicular to the xy plane, and that also passed through the point of the application of f sub 2. And I found that the simplest way to do the torques for this example is to multiply each force by its lever arm. So the lever arm for f sub 1 is going to be right here, which is 2.44 meters minus 1 meter is equal to 1.44 meters. And the magnitude of the torque due to this force is going to be the torque is equal to F times R perpendicular, and that is F sub 1 times 1.44 meters. And since the beam is uniform, its center of gravity is at its midpoint, and you can kind of imagine the entire gravitational force to act at this point. So the lever arm for the gravitational force is going to be our equation here, which is 1/2 times 2.44 meters is equal to 1.22 meters. And the torque due to gravity has a magnitude of torque is equal to F times R perpendicular. And I put in my values for that, which were 425 newtons times 1.22 meters. And I get that as 518.5 newtons times meters. And now the torque due to F sub 1 is negative, since if it were the only torque, it would make the beam start to rotate clockwise about our chosen axis of rotation. And the torque due to gravity is positive, since, again, if it were the only torque, it would make the beam start to rotate counterclockwise. So therefore, I get the equation here, which is the sum of the torque is equal to negative F sub 1 times 1.44 meters plus 518.5 newtons times meters is all going to be equal to 0. And now this allows me to solve for F1. So in solving for F1, I use the equation of F1 is equal to 518.5 newtons times meters divided by 1.44 meters is equal to 360 newtons. Now, since the other condition for equilibrium is that the net force be 0, I get the equation here, which is sum of the forces in the y direction is equal to F sub 1 plus F sub 2 minus mg is equal to 0. And this allows me to solve for F2 using my values here of 425 newtons minus 360 newtons is equal to 65 newtons. And again, this is the upward force that is exerted on the beam by the carpenter, by each carpenter.